All right, friends and neighbors, I thought we would change tack just a little bit here and work with some tools rather than a configuration or more math stuff. So without further ado, it's tool time. Let's talk a little netstat. All right, one of the really important things to us when we are trying to either set up, configure, troubleshoot, secure our networks is that we got to find out some network information. And the basic network information can be found on your host with ipconfig or ipconfig/all. And then on a Linux host, we can use ifconfig, we can use IPA. And the things that we're going to get from this will be stuff like our IP address, MAC address, DNS, gateway, and we can also get our IP version 4 and IP version 6 information. So those are really, really important details. And they're also really nice to use for when we change a network configuration to run these commands on the command line to see if they were actually taken by the operating system. So good tools to have in your toolbox. Now, one of the things that I'm very fond of saying is that tables are really, really important. When we are talking about hosts and networking devices, we have a collection of tables that we run into all the time. We've got a host routing table, a host ARP table, we have a switch source address table or MAC address table. We have a router ARP table. We have a router routing table. If we're talking about wireless, we've got association tables. So the tables are really, really important, and every one of them is a little different. They provide a mapping between usually a couple of items. In this case, the ARP table is a mapping between IP addresses and MAC addresses. And so on a Windows host, we would use ARP-A, and then we could also force entries with ARP-S, ARP-D. On a Linux host, we would traditionally have used the ARP command, but the newer version of the command is the ipneighbor command, or ipneighbor. Right? And we can see from both of the outputs here that we have the similar kind of mapping. Right? I've just talked to this node, so I know that this MAC address goes with this particular IP address. And the whole point of ARP and the ARP table is to allow us to build a frame, right? Because when we want to build a frame to the destination, we need the MAC addresses. And so the address resolution protocol gives us the MAC address of the destination to which we are going to address the frame. I suppose we should mention here that if we're doing IP version 6, there's no ARPing. Now, another handy table that we should get to know on our hosts, and this is true whether your host is an end host, right, just a user sitting there, or maybe a server of some kind, is that we've got the routing table that provides a mapping between network destinations and the interfaces that we're going to use to get there. Now, as we can see in the table, there's actually a little more information than that, but we have to remember that in order to determine a network destination, we take our first column here and AND it with the second column. Or we take the network address that we're looking for and we AND it with a mask. And we get the actual destination to see if there's a match between the destination that we're trying to reach and a particular routing table entry. Once we find the entry that matches, we have an interface to go through and then potentially a gateway if the destination is off of our network. And route-n will give us very similar output for the Linux host. All of these commands have some options associated with them, so you can get more or less information than what we're seeing here. And these are IP version 4 routing tables. We have the IP version 6 versions as well. So this video is about netstat. What is netstat? Well, let's add to what we know. Now we can pull a bunch of the same information using netstat. We'll see in a second that netstat is a little more powerful than that. But if we read the definition from Microsoft, right, if we go from the Microsoft documentation, we can see that netstat displays active TCP connections, ports on which the computer is listening, Ethernet statistics, IP routing tables, IP version 4 statistics, and so on. And the same is true on Linux if we take a look at the man page. Now, when you're on the command line for a particular operating system, you can see the options associated with a particular command right there, right? And we know that because we can look at the man page if we're on Linux, and we can use the /?, or sometimes no options at all, to give us the output on a Windows host. So if we were on Windows, it might look something like this. I might type netstat, right? And this gives me the default output, but I could also do something like this, and it would give me the available options with netstat. So this is a handy thing to remember. And on Linux, we might do something like this, right? If I just run netstat, it does the same thing, right? Default output. But we can always run the man page to get a little more information, or we could just do a lookup on the man page on the web. So what we're saying here is that while we have a collection of tools that we can use on the command line for traditional network information like IP address and routing tables, we also want to be aware that we've got this other fabulous tool that sometimes we don't leverage as much as we maybe ought to. So let's start with a couple of really basic examples of how we might use netstat. Some of the netstat usage can replace some of the tools that we've used before. So in this particular case, we can pull up the routing table. And so using the netstat-r, we can get the exact same output as the route print statements or the route statements on Linux. Now let's say we're interested in the statistics, right? How much traffic is being generated, what kind of traffic is being generated, are there problems with the traffic? And so netstat-s allows us to take a look at some of the statistics for an interface or a protocol. Now in this particular slide, I've just shown you the IP version 4, and I'm showing a comparison between the output on the different operating systems. Even though the tool is cross-platform, it's not always true that the output is exactly the same. And in this particular case, I'm showing IP version 4, but I could pull the statistics for TCP or UDP or ICMP or a variety of other things that are supported by netstat. So netstat-s if you want to know what's going on with some of the counters associated with your network connectivity. But the real power of netstat is to show us what's going on with our TCP and UDP connections. Now we know from our previous discussion of, say, the client-server architecture, that TCP connections go through a handshake to start up, they do a handshake to shut down, and then we've got servers that listen, we've got clients that connect. So netstat gives us a good way to see the status of all of our connections. Now here's the fun thing about netstat too. It's one thing to monitor a server, but every once in a while, it's kind of interesting to pull open netstat and see the myriad connections that are running from your particular machine. I'm not doing anything right now except recording, right? But if I ran netstat, there'd be dozens of connections going to and from my machine. What are all of those connections? So sometimes it's handy to take a look at that, because in addition to network packet traffic, why is this traffic flowing across the network? You can look at netstat and say, why in the world are these connections being established to my machine? So let's remind ourselves about a couple of things here, right? We know that we've got this handshake that is established. But before there's a handshake, right, a server will be listening on a particular port. And we can see that right here. We've got a couple of listening services. Now in this case, this was my VM that I was using from the previous SSH videos. And so that this VM is listening for SSH connections. So that's what a server is doing before anybody connects. And then, of course, we go through the SYN-ACK connection, and we eventually establish a connection. We do a whole bunch of stuff, and then we decide to shut down. But only one side decides to shut down at a time. And so we go through the phases of shutting down, the phases of the termination handshake. And so that's really what this page is about. Now, this set of states is right off the Linux man page. But we can sort of look through these and go, oh, wow, that's a lot of states. And I've got 2 more slides on them. But if we think about it for a sec, we go, okay, we've got a client that is starting to connect. And so one side of the connection has decided to connect. And then eventually the server will acknowledge that. And then they go back and forth and do the handshake. So we can see that there's sort of stages as packets are exchanged. Eventually, the connection is established. That is one that's already gone through the connection handshake. And then, of course, we've got the FIN flags of the TCP messages that indicate that somebody wants to shut down. if we follow along here, we also know that ports can be open, ports can be closed, sockets can be open, sockets can be closed. And so this is really about maybe a listener or a connection that was established, went through the termination handshake, and then shut down and is no longer in the process of exchanging data between the two sides. So just like the connection handshake goes through a set of stages, a termination also goes through a set of stages. And so that's what we see here: closed wait, closed, and things like that. And on this last slide, we see that we've got the listen state, or listening, depending on which operating system you're talking about. And this is pretty straightforward, right? You're running a server like SSH, and you're waiting for connections. So there's nothing going on at this point. You just got a server with an open port sitting there waiting for clients to attempt to connect. Closing is pretty straightforward, right? We have the act of closing. But one of the things that's interesting to note is that when you have a connection established, the two sides are potentially sending each other data. One side decides to terminate, but that doesn't necessarily mean that the buffer is empty, right? We might have data that is still being in the process of serialized for transmission. And so we've got to wait for those buffers to clear out. And so we've got a couple of different states as we start up the connection and a couple of different states as we close the connection. So I wanted to go back to this slide before we close up this particular video. You can see that on my host, we've got a number of TCP-based connections. Now you can specify whether or not you want to talk about TCP or UDP. We know that different applications use different transport layer protocols, but we can see here on the output various states that these are in. And so we've got listening, we've got established connections, we've got connections that are in the middle of shutting down. And then associated with this output, we can also see that we've got IP addresses and then the port to which that connection belongs. And we can also see that it says SSH here, but what that is the operating system being very friendly to us. And it's doing name resolution on a particular port. So this would normally be 22. Okay, and so we've got both of our Windows host here and our Linux machines showing similar state labels for the various connections. And this is only a tiny snippet of all of the connections that each one of these machines have. So do we love netstat? Oh yes. Understanding network information is really, really important. When we're getting started, things like ipconfig, ifconfig, IPA, these are all very, very handy. When we're moving to the next level, we start to think about tables. arp-a, route print, but now we know that we have this other fabulous tool that's out there that can not only give us another way to access some of the same information, but gives us access to all of these other details regarding the TCP and UDP connections and all of the connection statistics associated with a particular node or host. So we have lots of tools. Make sure that you add netstat. Hey, like and subscribe if I helped. And now that we've got netstat in our toolbox, we can make sure that those packets get to their destination.